is the third video for the November 16th class. This one we're going to expand a little bit upon the base cost operations to introduce cost allocation, and also use that as an example to talk about something that you've probably seen in the past couple times you've run this tool, which is source characteristics. So in order to make this work, I dragged in dorms from the data. And, if the first question that we asked was, okay, if I, excuse me, permit myself a grid like this where it costs me 0.21 seconds, to walk on every cell on the path, 0.4 seconds to walk on every driveway, and then 0.5 seconds to walk in the grass because it's snowy. And then we took an origin point here. We were able to calculate the essential seconds that it would take to walk from that point, right? So any other point on the map, we could know how long it would take to get there. So what if we wanted to ask a slightly different question, which is ignore the origin. Pretend instead I have these two dorms, right? One here and one that happens to be here. If that is the case, and this is where I'm coming from, where are all of the areas on campus where I could get here quicker than I could get to here? So essentially we want to take this, the seconds map, the cost grid, right, how much we're charged in seconds, and find out where that cutoff is, where it would have taken more time always to get to, it would take less time to get to this one than get to that one. So we're defining zones of influence. And you do that with what's called cost allocation. So it's right here. We can come in and we can drag in dorms, right? That's where we're originating from. Give them the value of population to differentiate that they're two different dorms. And add in your cost raster, which is the cost grid, how much you're charging in seconds. Then we'll just call this the cost allocation. And what's going to come back to you now is not a grid where every cell tells you the seconds that it takes to traverse, but a grid that just gives you two values. This meaning you're closer to the one whose ID is 200, right? And I can see that by grabbing this and coming down here and clicking and finding out, hey, your value is 200. Right? So all the green cells are closer to 200 than they are to this. And it's interesting that you see these ones on the outskirts, like, wow, look at that, the other side of the street is technically closer. Well, not in a Euclidean fashion, but in the model we set up where you have to walk up, cross at the crosswalks, it's actually quicker to keep traversing up here than it is to come down this way and find your way. So that's cost allocation, right? Quicker in terms of time, given the parameters we set up to get here, than it would be to get here at every point up until this demarcation line. So this is actually a good way to teach something. What if, we were running the same calculation, but let's say for some reason this dorm has like a super janky security system that just like adds an unnecessary amount of time to be able to get into it. We'll say it adds like an extra 60 seconds or something. And because it adds that 60 seconds, you'd want to reflect the fact that maybe there's this other delta somewhere where, I can actually get to this maybe in some of these areas here a little closer because I need to account for the fact that once I get here, I'm waiting. I had to do this analysis once for work in which you looked at a couple of different hospitals in a part of North Philadelphia or clinics, and then you assess them by their waiting area, right, to see which one was actually closer to you depending on where you lived, so that you could theoretically live farther from one health center, but that health center might have a shorter wait time than the other, so it would technically be closer. So in order to do that, I'm going to come into the dorms file, and I'm going to set something that just add a field that says extra seconds. And I'll just make sure the 151, which is the one up here, has a value of 60. And so it's going to add itself 60 extra seconds when calculating the total time that it would take to get there. Leave the other one 0. And I'll run the same operation. I'll break open cost allocation. Dorms is my source, right? I'm still using the population as the ID because that identifies their difference. Oops, apologies. I'm going to drag in the cost grid, right? That's the one that tells me how much it costs to travel on each cell in terms of seconds. And I'm going to come to the bottom where I have source characteristics. Now, we're not going to run through each of these. We're just going to do one of them, but I'll give you a quick heads up on what each does. So the multiplier is just something that gets applied to all the fields that multiplies what the cost is, by some additional value. So the way I've often thought about this one is different travelers. Like, let's say you have, you're someone on a bike versus someone on a on like a car versus someone walking. You might want to have like the base cost be the same below, but then say that the biker can go 2 times as fast as the walker, and then the car can go 10 times faster than both of them. That's a multiplier. Start cost is what we're actually going to do right now. This adds something to each of them. And so essentially what we're adding here is that we know that there's this wait time to get into the building. So I'll take this field where we said extra seconds, and that's what it's going to do. It's just going to add 60 to this, and it's going to add nothing to that. Some of the other ones, in case you ever get interested, you have a cumulative cost. I like to call that one like the grandmother or the grandfather cost. So like if you're walking with your grandfather, you could also choose to account for the fact that every step you take, you're probably feeling just as good as you were the step before, but every step your grandpa takes, he might actually be feeling more tired. So maybe you want to put something in here kind of like, what's the name of that? Compound interest. So that every distance you get, like a multiplier, starts to increase over time. Capacity is just a cutoff point, like they can't travel past a certain distance. And then I imagine never used travel direction for, so I won't speak too much on kind of what that is. I'll stick to the ones that I know. So again, start cost. We're using the field extra seconds, and we'll call this cost allocation 2. Let it run, biggity babbity boo. And some subtle changes right here, right? So there's a little bit of difference that we start to notice. The actual distance actually changes a little bit from one to the other, right? It reflects the fact that there would need to be this weighting element. So you are actually a little bit closer to this one here, because even if you went that direction, you'd be charged that kind of weighting cost at the end of your algorithm or of your operations. So that concludes the third video. What I'd like you to do for this one, obviously, is just run the same processes and show me, a couple of cost allocation maps. You can choose to use the start cost that I used, or if you liked one of the other ones, you can play around and try capacity or, try cumulative cost or something like that.